Statistically Significant Mini Project 2, Team 17, Riley Maurer, Ren Trang, Todd Kremeyer, and Reggie Smith. Mechanical engineering is being in the profession of researching, designing, and testing mechanical systems. The focus is given to subjects such as materials, thermal fluid systems, and machine design. Emphasis on mathematical analysis and communication skills. Product of their work may range from small mechanisms and full-scale machines for a myriad of applications. Life of a materials engineer. Firstly, we study materials at the atomic level. Studies include metals, ceramics, plastics, composites, and nanomaterials. And we develop, process, and prototype materials for a wide range of products. Typically, a materials engineer would be analyzing the structure of certain materials using computers and design equipment and determining which material are most efficient and cost-effective are extremely important when designing a prototype for a project. The analyst of the material chosen will give the engineers a general idea of how well the design will work. Further analysis leads to the engineers to use statistical data in the design of the product. Important data used for manufacturing engineering. A couple of the top three is main production process, inline testing, and sampling. And this is quality management, production management, and overall equipment effectiveness when making a product. The next one is work in progress and intermediate inventory stores, inventory management, and quality management. And another important one is the end of production line, production management, overall equipment effectiveness, and inventory management. Of how statistics help with analyzing data in manufacturing. There's a couple different things in here, and in manufacturing, business can use data collected over time at different processes and apply statistics to this data and identify patterns and relationships among different process steps. In the graph, it shows you some of the different ways that how they figured out those different patterns. And with this information, businesses can then optimize different factors of the manufacturing process that prove to have a great effect on the cost of making that product. When manufacturers are looking at the total collective data, they can find patterns and relationships that they might not have been able to recognize otherwise. So using statistics in manufacturing and by recognizing one relationship pattern, the company could save millions a year without any cost to implement, like we said on the last slide. There's a story here of a manufacturing company back in the 1990s that actually almost all the companies looked to how to manufacture their product because they were so effective at manufacturing. And one person said they should use statistics and analyze what they could do to improve. And everybody thought there would be nothing to improve. And when they did that, they actually were able to do a 20% reduction in manufacturing cost. And also they were able to reduce 15% of how much energy it took to manufacture the product. So with that, as you can tell in this graph, you can see just from 1997 is actually when they started using statistics and analyzing how much it has increased just in 13 years per the output per US worker. It's almost doubled within that amount of time. That's how important statistics are. And as engineers, that's our main thing, is to make things more efficient, make it better, and that's what we're going to be asked to do when we work at different companies. Grand challenges are challenges that the National Academy of Engineering places before all engineers as challenges that the world faces together. Some examples of these challenges include improve urban infrastructure, advance personalized learning, and provide access to clean water. These challenges are challenges that we will face in the coming future, and it's going to take more than one type of engineer to solve it. We as mechanical engineers can work on these challenges in this way, and let me show you. Our grand challenge that we as mechanical engineers hope to face in solving the problem of improving urban infrastructure, as quoted, infrastructure is a combination of fundamental systems that support a community, region, or country. Society faces the formidable challenge of modernizing the fundamental structures that will support our civilization in centuries ahead. In mechanical engineering, engineers like us look forward to providing better solutions for the mechanical manpower that urban infrastructure needs to improve. We indirectly, through advancements in moving machines like these pictures above, affect the overall rate at which we can improve urban infrastructure. Advances in more powerful machines, more efficient machines, and machines that can accomplish more also affect the rate at which we can fix the problems with our water and power supplies, as well as the transportation networks that across this country.